Alright, hello everyone, my name is Kunal Gupta and I welcome you all to PW Gulf. So I know your physics exam is done on 21st of February and the reactions I had got okay, based on the exam pattern was quite mixed, right? A few said it was easy, a few said it was moderate and others said it was difficult. The common thing is that those who were having the set 3, they said the paper was difficult, right? The other two sets the students reacted like it was moderate to easy, right? Let us know in the comment section which set you received in the Gulf region and according to you was it moderate or tough, so that we can get an idea, like based on the polls we would be having. We may post a poll in the community group as well, right? So that we get to know which set was tougher. And do not worry, if the set was difficult, then checking would be accordingly, right? Okay, so you can expect that if the set 3 was difficult, then it would be, the checking would be a bit lenient, right? So here we are going to discuss not only the answers but also the solutions of each and every question that came in the board exams on 21st of February, right? Quickly comment in the chat box how is the Josh. So without any delay, let us begin. So hello everyone, my name is Kunal Gupta and I welcome you all to PW Gulf again. चाय पी लो कहीं से, स्वाद मिलेगा यही से. Drink tea from anywhere, but you will get taste only from here. Saying this line after a long time, right? So let us begin. So this is the paper that I am going to discuss, है ना? The solutions I am going to discuss of the paper in the Gulf region, right? Let us start. So as you know, the section A, it starts with the 1 marker and the MCQ you can say. So let us read the first one. Which of the following rays, keep commenting us like which is the correct option you had marked for the respective questions. So question number 1 said, which of the following rays coming from the sun plays an important role in the maintaining the earth's warmth, right? Okay. So which all rays come from the sun, right? The visible light, right? The UV rays and the infrared. Visible rays, UV and the infrared. Okay. The UV rays get blocked by the Earth's atmosphere and it's the infrared which maintains the Earth's temperature, or you can say the warmth on the Earth. So option number A would be correct here. The effective capacitance of the network between points A and B shown in the figure. So here is a system of 5 capacitors shown to you. You need to find the effective capacitance between points A and B. Very simple. First thing, whenever 5 capacitors are there, check whether it is in balanced condition or not. Okay. So very simple thing I had explained you. This into this is should be equal to this into this for the system to be in balanced condition. This is C1, this is C2, this is C3, this is C4. So find C1 into C3. Okay, C1 into C3, that is 3 into 12, that makes it as 36. Find C2 into C4, 6 into 6, that again make it as 36. So this is in balanced condition. The thing that you can do is remove the 1 microfarad wala capacitor, right? Now draw the equivalent of this. If you want, you can maintain the shape. A and B, so 3, 6, 6 and 12. Okay. So these two are in series with each other. Okay. So their equivalent capacitance will be how much? 3 into 6 upon 3 plus 6, that makes it as 3 plus 6, 9. 6 into 3, 18 by 9. So that is 2 microfarad. Okay. C equivalent dash you can do 6 into 12. 6 plus 12, that makes it as 18. This gets cancelled out on 3. This gets cancelled out on 4. 4 microfarad, right? Equivalent capacitance of these two, right? Replace them by two capacitors between points A and B. This is how much? 2 microfarad. This is 4 microfarad. 2 microfarad and 4 microfarad. These two are again connected in parallel, and the equivalent capacitance between A and B is given by 2 into 4 upon 2 plus 4, that makes it as 6. 3. 4 by 3 microfarad. Is it in the options? Yes, option number 1. Fine. So very simple question. We had discussed this question in the class, right? And we had discussed a similar question as well. Okay. The electric field at a point in a region is given by this. Okay, so it is given to us in the vector form. Alpha r vector r, and magnitude of vector r, where alpha is a constant and r is the distance of the point from the origin. The magnitude of potential at of the point is, okay. So electric field is given. What will be the magnitude? If I need to calculate, alpha into r upon r cube gets cancelled out. Okay. E will be given by alpha upon r square. Okay. Make sure you keep commenting which was the option that you had marked in the exam. Okay. Now we know that E is equal to minus dV by dr. Okay. So dV from here will be minus E dr. Integrating both sides. So here you get V. Minus of E can be replaced. The value of E can be put it from here. Integration of alpha by r square dr. Taking alpha common, integration of r square dr. Okay. Now integrate this. How much you are getting? Plus 1. R is to minus 2 plus 1. That makes it minus 2 plus 1 here. There comes a constant as well because it is limits are not there. R raised to the power minus 1 upon minus 1 plus C. V is equal to minus alpha upon 1 by minus r. V is equal to alpha by r. Okay. Now a negative sign will come because you can say the electric field is in the direction of decreasing potential, right? Okay. You can mark the option number 4. Fine. But some places I had found that option number 1 was also marked there. I do not remember exactly which source it was. Okay, but there they had marked alpha upon r as the correct option. Okay. Two coherent light waves, each having magnitude, having amplitude A. A1 is equal to A2. So you can say amplitude of first is equal to amplitude of second is equal to A. Superimposed to produce an interference pattern on a screen, the intensity of light as seen on the screen varies between. Okay. So what is the range of the intensity? Of course, it would be varying between minimum intensity and the maximum intensity. Okay. The range of the intensity would be this only, correct? What is the minimum intensity? A1 minus A2 whole square. Okay. So A minus A whole square, that makes it as 0. What is the maximum? A1 plus A2 whole square is equal to A plus A whole square. By the way, till now on YouTube, entire complete discussion, solution of each and every question with depth, I hadn't found much video. So this video is especially for you guys to verify your answers, right? And make sure you share it with your friends as well, है ना? So a plus a, 2a, that makes it as 4a square. So the range is between 0 to 4a square. Minimum to maximum, option number 2. Fine. A current of 10 by pi ampere is maintained in a circular loop of 14 centimeter. The value of dipole moment associated with the loop. So there is a loop. In this, there is a current flowing of 10 by pi ampere. Okay. In a circular loop of radius 14 centimeter, 0.14 meter. Okay. They're asking you the value of dipole moment associated with the loop. Area is pi r square. Pi and pi gets cancelled out. 10 by 0.14 whole square. Fourteen into 14, that makes it as 196. 0.196 is the answer, ampere meter square. Option number 3. Fine. Very simple it is, direct formula based. Again a similar question we had discussed in the class. Okay. So a transformer is a device used to. Okay. So first option says high voltage to low voltage, second is high voltage to low voltage, low to high, low to high. Okay. Okay. So what does a transformer do? First you need to understand. So there are two types of transformers, step up transformer and step down transformer. Okay. Step up transformer and step down transformer, both are having functions of changing the output voltage. Okay. Step up increases it and step down decreases it. Okay. So very simple, primary coil and secondary coils are there. So Vp into Ip is equal to Vs into Is. Okay. So what it does, if it increases the voltage, okay, AC voltage, then it increases the voltage. For example, the voltage was low initially, so the current must be large. It will be increasing the voltage, correct? But at the same time, it needs to lower the current because the product must be constant. If it is increasing one thing, it need to decrease the other. Okay. Arey bhai. So let us read the option high voltage, okay, low AC voltage, okay, large AC current to small AC current, okay. So high voltage is there and large current, no. High AC voltage, small current, low AC voltage, small current, no. Low AC voltage, large current, okay. High AC voltage and small current, ठीक, correct. Fine. Next, comment us which was the correct option that you had marked. 4 resistors, each of resistance R and key K are connected are shown in the figure. The equivalent resistance between point A and B when K is open will be. Okay. So they are asking you what will be the equivalent resistance between A and B. See, I had made you learn with the help of the potential, right? So at this point, let it be potential at the A point be VA. At B, it must be VB. Fine. Unless and until an obstruction comes, potential across the wire will be same. Again VV. Now, here is a point A. Potential at which is VA. Okay. Acha, let this point be X. Potential here it be Vx. Between A and X, I'm marking another point. Oh, I'm sorry. Here must be potential must be VA. X point, potential at X, Vx. B point, potential at B. So between A and X, one resistor is there of resistance R. Between X and B, one resistor is there. X and B, another resistor. X and B, another resistor. So three resistors are there between X and B. By the way, we had done this question in class as well as it is. Resistor R, resistor R, resistor R. Okay. Now this is a simple question where three resistors are connected in parallel with each other of same resistances, which in turn is connected with another resistor. Okay. So what will be the equivalent of these three? So 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that will become 3 by R. So R equivalent will be R by 3. So this R by 3 is connected in series with this. Okay. Equivalent of these two will be R plus R by 3. 4R by 3. Okay. Fine. Clear? Clear? Type in the comment section if you had marked the same. Which of the following electromagnetic waves has the photons of largest momentum? Okay. So lambda is equal to h upon mv. Okay. So lambda is equal to h upon p. So p is equal to h upon lambda, or you can write p is inversely proportional to the wavelength, right? So the radiation, whichever radiation would be having the least wavelength, will be having the most momentum. Okay. So they are asking about the largest momentum. So whichever would be having the least wavelength would be having the most momentum, right? Fine. So let us move ahead. For this you need to learn that code. Mr. CY said to Mr. X that you are a very intelligent media radio partner, right? Okay. Largest it is no, huh? X-ray. Okay. Acha, by the way, similar question we had done in the class. Okay, this one we had done in the class. The kinetic energy of alpha particle is 4 times the kinetic energy of a proton. The ratio of de Broglie wavelengths associated with them is given by. Okay, very simple. So they are asking you the ratios of the de Broglie wavelength. Okay, lambda of, oh sorry, so there is an alpha particle and a proton. A proton is there and an alpha particle is there. Mass of the proton, let it be m. Mass of the alpha particle 4 times m. Kinetic energy of the alpha particle, kinetic energy of the proton, let it be k. Kinetic energy of the alpha particle, let it be Okay, it is given. Kinetic energy of the alpha particle is 4 times de kinetic energy of the proton. 4 times K it will be. Okay. And they are asking you the ratios of the de Broglie wavelength. So again, it is very simple. Which formula you are going to use? Lambda is inversely proportional to uh, under root m into k. Lambda is inversely proportional to under root m into k, where m is the mass of the particle and k is the kinetic energy. So lambda of alpha particle to lambda of photon they are asking. Okay. So under the root mass of the photon into kinetic energy of the photon. Mass of the alpha particle into kinetic energy of the alpha particle. K gets cancelled out, gets cancelled out. Root of 1 by 16, that makes it as 1:4. Option number C. Fine. Do comment us and let us know what was the correct option that you had marked in this. A glass slab of this much refractive index and thickness this much is placed over a paper. The shift in the letters printed on the paper. So this is the formula on shifting through a glass slab. So direct formula based it is. So shift is given by thickness into 1 minus 1 by mu. Thickness is how much? 6 centimeter. 1 minus 1 by 1.5. 2, 3, 3 minus 2, 6 into 3 minus 2, 1, 1 by 3. 2 centimeter is the shift. Option number A. Fine. The dimension of 1 mu into E, where E is the permittivity, epsilon is the permittivity and mu is the permeability of the medium. Okay. So we know that P is equal to 1 by under root mu into epsilon of that medium. Square both sides, C square is 1 by mu into E. Now, they hadn't asked you mu into epsilon raised to power minus 1 by 2 or 1. It's minus 1. Minus 1. Okay, so this is what they are asking you. Raised to the power minus 1 is equal to C square. What is dimension of this? This is speed of light. So LT raised to the power minus 1. L square T raised to the power minus 2. L square T raised to the power minus 2. Okay. Option number B. I hope you would have marked this was direct formula based and simple. Okay, read this. I got to know most of the students. A lot of you were not able to do this. So read this. A charged particle gains a speed of 10 raised to power 6 meter per second, right? And when accelerated from rest to a potential of 1 kilowatt, okay. And they are asking you enter the magnetic field of 0.4 Tesla, and such that V is perpendicular to B, the radius is given by. Okay. Now, okay. So this is the general formula that you would have seen. ठीक है. You would have seen this formula as well. If it is a charged particle is accelerated through potential V having mass mu and charge q, this is the formula that we use. Okay. If you want, you can take this qb inside. Under root 2m qv upon qb. Q square b square. Okay. So q and q gets cancelled out. Under the root 2m q into v by b square. Okay. Now, they had told that this much is the speed it has gained when accelerated through this much potential. Okay. Now, the kinetic energy is given by Q into V. Kinetic energy is given by Q into V. This is nothing but half mv square. Okay. M by Q will be V by V square into 2. 2V, V square, this. So, this M by Q value, can I substitute here? The answer is yes. I had done nothing, but I had found the value of M by Q and I am substituting here. That's it. This is given by twice of 2V V square into V by V square. Or you can write 2 capital V upon small v into b. Okay. So, this is the formula for r, that is the radius of the circular path. You may substitute the value. This is 10 kilovolt, volt, so you can write 10,000. Speed is how much? 10 raised to the power 6. And b is how much? 0.4 Tesla. Okay. All of you are going to get this in meter. Multiply this by 100 and you get it in centimeter. 1, 2, 3, 4, 5, 6. So 5 centimeter. Option number B. Clear? Any doubt? Any query you have? You may not be able to ask me because it's a recording one. Okay. In Rutherford alpha scattering experiment, the presence of only few alpha particles at an angle of scattering alpha at a scattering pi led him to the discovery of the nucleus. The size of the nucleus is approximately 10 to the minus 5 times smaller than that of the atom. Therefore, only a few alpha particles rebounded. Okay. Okay. So yes, it is correct because nucleus, it is present in a very it's there at a very small region, right? For example, the room is there, then the tip of this pencil is the size of the nucleus. Okay. The Balmer series in hydrogen atom spectrum is found when the electron jumps from higher energy state to the ground state. False. Lyman-Balmer, when it jumps to n is equal to 2. In Bohr's model of hydrogen atom, the electron can jump between successive orbits only. False. A is false, but R is also false. And R is false. Should be and R is false. Okay. During formation of nucleus, the mass defect produced is the source of binding energy of the nucleus. Okay, true. For all nuclei, the value of binding energy per nucleon increases with mass number. Okay, not necessarily for all nuclei. This is false. We had seen that there is a drop after a certain point. So A is true, but R is false. The impurities in p-type semiconductor are not pentavalent. So what is p-type semiconductor? In which holes are in excess. And you need to add an impurity which is trivalent. Or you can say not pentavalent. Okay, so this is true. Okay. The whole density in valence band in p-type semiconductor is almost equal to the acceptor density. True. Okay, fine. So assertion and reasons so were comparatively easy. Okay. Now 17th question is an OR part, so you have to do one of them. We can try any of the two. This is lambda by 3. Lambda by 3. Okay, let us try then this one only. In the Young's double slit experimental setup, the intensity of the central maxima is I naught. Calculate the intensity at a point where the path difference between the interfering waves is lambda by 3. Okay. Okay. Now, what is the formula for intensity? I1 plus I2 plus twice of root of I1 into I2 cos of phi. Okay. 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 They are saying the intensity of the central maxima is I naught. When I say central maxima, delta x is 0, path difference, correct? How much will be the phase difference? That will also become 0. Substitute the value of phi here as 0. Acha, and I1 is equal to Young's double slit it is. So we consider I1 is equal to I2 is equal to I. Okay. Acha, your final answer should be in terms of I naught only. So at the central maxima, they are saying the intensity is I naught. So in this formula, instead of I am going to write I naught. I plus I plus twice of I into I, that makes it as I square. Cos 0 degree, that is 1. I naught is I plus I, 2I plus 2I, 4I. I will become I naught upon 4. Okay. Now, at some other point, they are saying where the path difference between the two interfering waves is lambda by 3. Delta x is lambda by 3. Delta phi is 2 pi by lambda into delta x. Delta x is how much? Lambda by 3. 2 pi by 3. This is the phase difference. 2 pi by 3 you can say, or this is nothing but 180 you substitute, 360, 60, 120 degree it is. To 120 degree, correct. Okay. Okay, now substitute the values here in this. Intensity at this point be I dash, so I plus twice of I into I into cos of 2 pi by 3 or cos of 120 degree you want to substitute, you may. So what is cos 120 degree? Cos 90 plus 30, or you can write 180 minus 30 degree. Okay, cos of 30 degree. So that is how much after school? So this will be negative minus root 3 by 2. I dash is twice of I plus twice of I into root 3 by 2 minus root 3 by 2. This gets cancelled out. 2I minus root 3 times I. This is 1.7, so you can write 0.3 times I. I dash is how much? 0.3 times. I is given to you as I naught by 4. So roughly this is the answer. If you want, you can keep it in terms of root only. That is also possible. Hai na? 2 minus root 3. Okay. Next, a wire of resistance x ohm is gradually stretched. So the resistance of the wire was x ohm. Length let it be L. Is gradually stretched till it becomes twice its original length. L2 is how much? Twice of L. R2 is how much? 40 ohm given to you. Find the value of X. So we had studied R2 is equal to L2 by L1 whole square into R1. Similar question we had done in the class, and I had told you this shortcut to be used. Twice of L upon L whole square. R1 is how much? X. R2 is how much? 40. Then it gets cancelled out. X you are getting it as 10 ohm. Fine. Clear? Anji, yes. Clear or not? Okay. I know a few of you are very much disheartened like after giving the exams, but don't worry. You would be getting the marks proportional to the hard work you had done. Okay. Not less than that, and of course not more than that. Okay. You have done your part. Just focus on the next exam. That's it. Okay. Result, it's leave it in the hands of God now. Okay. A circular coil of 200 turns is placed in a horizontal plate, carries out this much current. Find the magnitude and direction of magnetic field at the center. Okay, so very simple. How many turns are there? 200 turns are there. What is the radius of each turn? 4 centimeter. 0.04 meter. Is placed in a horizontal plate, carries a current of, how much is the current? 0.4 ampere. In a clockwise direction, find the magnitude and direction of the magnetic field. Okay. Okay. Let me draw a circular loop. Clockwise it is moving. Call your fingers. Magnetic field must be downwards at the center. Okay, fine. Number of turns are 200. Then easily you can calculate, right? The net magnetic field, you can apply the magnetic field formula directly. What is the magnetic field at the center? That is given by mu naught I by 2r. Right? Number of turns are 200. You multiply it by 200. Okay. Solve this, you will get the answer. Okay. Chalo, let me solve this. 4 pi into 10 raised to the power minus 1. Current is how much? 0.4 ampere. Number of turns are 200. Twice of R is 0.04. 0.4, not 0.4. 0.04. Whatever is getting cancelled out, you may cancel it out and solve it. Okay. Calculation part I am leaving it because we need to discuss a lot many questions. Now, acha, one thing that I observed, derivations this time very less weightage it had. Okay. Generally this doesn't happen. Okay. A good chunk of derivations. Okay. 15 to 20 marks, 20 marks around, it's based on the derivation part only, but this time the derivations were less. Okay. Till now we hadn't seen any derivation, correct? Why is the mass of the nucleus always less than the sum of the masses of the constituents, that is the neutrons and the proton? So we know that this mass defect is converted to the binding energy. So basically they are saying, so if we are having the individual nucleons, nucleus is formed because of this nucleons only. But this mass of this nucleus is less than the constituent nucleons. Why? Because of binding energy. Yes or no? How is Coulomb's repulsion between protons in a nucleus overcome? Okay. So all of us know that supposedly we have protons. Positive charge to repel each other. ठीक है. So that is the repulsion Coulomb's force. ठीक है. Due to which they should have moved apart and the nucleus would have been unstable, but this doesn't happen. Again, this question we had already discussed. Both of these questions were discussed in the class. Okay. Hanji, so basically what happens? There is concept of strong nuclear force. Okay. Since the nucleons are very close to each other, right? So there acts the strong nuclear force, which is much larger than this electrostatic force, Coulomb's repulsion force, you can say, right, which helps in overcoming this. The threshold frequency for a given metal, it is given by 3.6 into 10 raised to the power 14 hertz. If monochromatic radiation of frequency this much hertz is incident on the metal, find the cutoff potential for the electron. ठीक है, तो we know that E V naught is equal to H F minus H F naught. Formula just I am applying. F naught is equal to H. You can take common F minus F naught. ठीक है, so you can calculate the cutoff potential from here. 6.6 into 6 into 10 raised to the power minus 34. Planck's constant. 1.6 into 10 raised to the power minus 19. F minus F naught. 6.8 into 10 raised to the power 14 minus 3.6 into 10 raised to the power 14. Ten raised to the power plus 19 I am writing, 10 raised to the power plus 34. Take 10 raised to the power 14 common here. ठीक है. Inside 6.8 minus 3.6 you are left. How much is this? Solve this. 0.54 4 5 6 4 4.1 roughly. Solve this. 10 raised to the power 19 into 10 for 19 plus 14, that makes it 10 raised to the power 33 upon 10 raised to the power 34. 6.8 minus 3.6, right? How much is it? 3.2. Solve this, you will get V naught. Now it is very simple. 4.1 into 3.2. Roughly 13 something you would be getting. 10 raised to 1 2 3 you can write. So roughly 1.312 volt is what you are getting. Cutoff potential. Everything is in the SI unit, na? Yes. Okay, fine. I believe a similar question we had discussed in the doubt session, right? This is an application based, so whatever you are, again it is an odd part, we can do one of them, or I can tell you the concept behind both of them. Okay. Two small solid metal balls A and B of radii capital R and 2R have the charge density 2 sigma and 3 sigma. The question we had done, it was given same charge density anyways, are kept far apart. Okay, okay. Find the charge density on A and B after they are connected by a conducting wire. Okay, radius is r and 2. Radius is r, this is 2r. This is 2 sigma, this is 3 sigma. Charge density. So charge density we know. Acha, charge initially, let us suppose it had q1, this had charge q2. This is charge per unit area. This is 2 sigma. A1 is nothing but this area of this 4 pi r square. Q1 is how much? 4 into 2, 8 pi sigma r square. Okay. What is this? Q2 by A2, 3 thrice of sigma. Four pi, radius is how much? 2r, 2r square. So Q2 is how much? 3, okay. 4 into 3, that makes it as 12 pi sigma. 2 square is 4 into r square. 48 pi sigma r square. Now this is the charge on one and this is the charge on second. In the question, they are saying now you had connected these two spheres with a wire. Okay. So what will happen? Charge redistribution is going to take place. This will have charge q1 dash. This will have charge q2 dash. Now they are asking you the values of these charges. Okay. But suppose here total charge was q1 plus q2. This total charge is going to remain conserved. q1 dash plus q2 dash. This total charge will remain conserved. Fine. Okay. So potential of this is V1, potential of this is V2. V1 is equal to V2. This is nothing but K Q1 dash by R. Acha, radius also remains same. Radius is R, radius is 2R. K Q2 dash by radius is 2 ice of R. K gets cancelled out, R gets cancelled out. Twice of q1 dash is equal to q2 dash. Okay. Now if you want, you can apply the conservation thing here. This is equal to this. q1 plus q2 is equal to q1 dash plus q2 dash. So 48 plus 8, that makes it as 56. Pi sigma r square. q1 dash plus q2 dash, this is one only. q1 dash plus q2 dash can be substituted as twice. This will become thrice of q1 dash. Achha, what they had asked find the charge densities on A and B. Okay. So charge densities on A and B, this will be nothing but charge per unit area. Again, charge per unit area. Fine. Okay. All right. So q1 dash can be calculated from here. You may substitute the value here. Similarly, q2 dash can also be calculated from here only. Okay. Similarly, q2 dash can also be calculated from here. That is double of this. 112. Fine. You may substitute the values here and you will get the answer. Okay. Okay. Again, this was slightly lengthier. Okay. So better if you would have tried the second one. Second one is slightly easy. Two infinitely long straight wires 1 and 2 are placed at d distance apart parallel to each other as shown in the figure. They are uniformly charged having densities lambda and minus lambda 2. So, this is positively charged and this is negatively charged. Locate the position of the point from wire 1 at which the net electric field is 0. Identify the region where it lies. Okay. Alright, so we need to find the region where the net electric field will be 0. Now, let us first talk about region P and pick any point. This is positively charged, this is negatively charged. Electric field due to this, let it be E1, electric field due to this, let it be E2. Acha, electric field due to infinitely long wire, it is given by 2k lambda by r, where r is the distance. Okay. Okay. This is positively charged, electric field will be away from this. This is negatively charged, electric field will be towards this. They are asking net electric field must be 0. So, here to both are lying in the same direction. R in B region B electric field cannot be 0. Net should be 0. They are saying net electric field must be 0. So, if one is acting in left direction, the other must be acting in the rightwards direction. Is it possible here? Okay, let us see. E1 would be acting here, E2 would be acting here. Okay, yes, they are acting opposite, but is it possible here? See, the charge density of this is lesser than the charge density of the wire 1. Okay. The further you move, the electric field will be less. If at any distance you calculate electric field due to wire 1 E1 here, fine, and for E2 already this, they had given this is the charge density, lambda dash you can write because they had written in terms of lambda, na? So write it as lambda dash. Na? Already lambda for this is less, further you had moved this is close to this and farther from this, okay, and you had increased the distance, so electric field due to this is going to reduce. So this E2 won't be able to balance E1, first due to this charge densities lambda and lambda by 2, and secondly due to distance, fine. So there won't be any point in region A as well. Now see the region C, let us pick any point. E1 would be acting in this direction, E2 must be acting in this direction, both are acting opposite, so they must cancel out each other. See, here though density has lowered, but the distance is also less. Since you had reduced the distance, so this would balance out each other, so this E2 can easily balance this E1. So the region would be region C. And they are asking you to locate that point as well, okay, at where is that point? Okay, I may solve this here only. I am seeing that point is here. This is lambda by 2. Negative it is. This is at a distance x. Let this distance be d. Let this distance be x. So we need to find from wire 1. So this will be d plus x. So d plus x is what you need to find. Okay. Electric field due to this positive, it must be in this direction E1, that is 2k lambda by d plus x. E2 is in this direction, that is given by 2k lambda by 2, distance is x. So balance them, E1 must be equal to E2. X is equal to d. Correct? Let me just check the calculations. E1 must be 2k lambda by x. gets cancelled out, k lambda by x. 2k lambda by d plus x, x is equal to d. So total d plus x will be distance from the first wire, d plus x, d plus d, that makes it as 2d. Fine. So this was more of application based. This was more of application based. Okay. So that's why student may would have found this one as a bit difficult. Okay. Very simple. Draw the energy band diagram for, let me turn on the AC. Energy band diagram for conductors, semiconductors and insulator at 0 Kelvin. Very simple. Okay. So we know that these bands are going to overlap. Some energy gap would be there. Energy gap would be more. Conduction band, valence band, conduction band, valence band, conduction band, valence band. So here energy gap is almost 0 electron volt. Here the energy gap is less than 3 electron volt. Here the energy gap is more than 3 electron volt. Okay. Carbon and silicon both are members of fifth group, right, of periodic table and have the same lattice structure. Same lattice structure, right. Carbon is in an insulator, whereas silicon is a semiconductor. Okay, fine. So very simple. Reason being, carbon is having more energy gap as compared to silicon. Okay, that's why. See, insulators, they are having higher energy gap. Okay, though they belong to the same group, but the thing is that carbon is having more energy gap as compared to silicon. So the conductivity is highly low if you compare it with silicon, which is having a lesser energy gap. Let us know in the comment section what is the energy gap for silicon, right, and germanium as well. Okay, another application based question, good question it is. I know. A capacitor of plate area A and separation D is charged by a battery to voltage V. Okay. So what is the initial condition of the capacitor? Distance is D, area is A, distance is D, charged by battery to voltage V. Okay. So capacitance becomes epsilon naught A by D. Okay. Charge to V. So energy initially will be Q square by 2C. You can write. Okay. Epsilon naught A by D. Okay. You may write, acha, charge on this, let it be Q. Okay. So you can write Q is equal to Cp. Fine. That's it. Okay. Now, the battery is disconnected and the plates are slowly pulled apart till the separation becomes 2D. Now, what has changed is the separation between the plates. Which is now 2D. Area remains same, this has become 2D. Now, first let us see what will happen to the capacitance. C dash is epsilon naught A by 2D. Okay. So C dash is epsilon naught A by 2D. Okay. What will happen to V? Acha, charge will remain same, charge will not change, V will change. Okay. Can I write Q is equal to C dash into V dash? Yes. Into V dash. Okay. Or you may write V dash Also you can write q by c dash it is, है ना. Okay. Potential difference between the plates. Okay, they had asked how will the potential difference change. Okay, so V dash is how much? Q by C dash. एक minute. Q by C dash it is ना. हाँ. Q is how much? This is Q. Epsilon naught A into V by D. C dash is how much? Epsilon naught A by 2D. V dash is twice of V. V dash is how much? Twice of V. Okay. Electric field between the plates. Okay. Okay. What will happen to the electric field? E dash is nothing but V dash by D dash. This has become twice. This has also become twice. So nothing will happen. V by D only. Earlier also it was V by D. Now also it is V by D. No change. Work done in pulling the plates apart. This work done will be equal to change in the energy, that is U final minus U initial. So you can find the final potential, final energy stored and initial energy stored and subtract them. You can use any formula, Q square by 2C, Q square by 2C dash. Again, the third part was a bit application based. Now, finally comes a derivation, whose solution had already attached. Using Huygens principle, briefly describe reflection of plane wave front from a reflecting surface, hence prove laws of reflection. We had already discussed this in the class. Okay. So we have to use the concept of wave front and then prove the both laws. Angle of incidence is equal to angle of reflection, and incident ray, reflected ray, normal all lie on the same plane. So both of these things, do not just leave it proving the first one. Okay, both we had to write. Okay. Again, this question we had discussed, I remember, in the doubt session. Fine. Now, let us. Okay, it's already an hour. An air bubble is trapped at point P. Cp is 1.75 centimeter. Okay, in a spherical glass of refractive index 1.5. Okay, and of radius 7 centimeter. So C to B, this is the radius, this is 7 centimeter, this is 1.75, 7, 8, 8.75. Okay, 7, 8, 8.75 as shown in the figure. Find the nature and the position of the image when viewed from side B. Show the image formation by drawing a ray diagram. Okay, so you are viewing from here, है ना? You need to view this bubble. ठीक है, अब bubble start. ठीक है, okay, fine, very simple. You can apply the formula N2 minus N1 by R is equal to N2 by V minus N1 by U. So you have the object distance, you have the value of R that is given to you as 7 centimeter. Okay. The value of V is what you need to find. Yes, will you be able to do it? Huh? See, incident rays are going in this direction, so take this direction as positive, opposite to that as negative. So U is in this direction, U will be minus 8.75 centimeter. Okay. Okay. R similarly minus 7 centimeter, you have to substitute here and you will get the value of V. Fine. Let us move ahead. Again, finally, one more derivation is there. Again discussed in class. Use Ampere's law to derive the expression for magnetic field due to an infinitely long wire, straight current carrying wire of infinite length. Fine. So Ampere's law is B dot dl is equal to mu naught into current enclosed. Simple, this we had applied. and calculated how much is the magnetic field at point P. Okay, fine. Now, when was the Ampere's law useful? It can be applied anytime, but when symmetry is there, it is very easy to apply and calculate magnetic field at any distance. Fine. On the other hand, in Biot-Savart law, you will have to take a current carrying element, then calculate the magnetic field. Remember, right? So, what is the advantage of Ampere's law here? The symmetry. Fine. The symmetry. So, that is why in the above question we had used the Ampere's law. Again discussed in class. Difference between half wave rectifier and full wave rectifier. Differentiate half wave and full wave rectification with the help of circuit diagram. Explain the working of the full wave rectifier. Okay. Okay. So I am explaining both of them to you guys. Here we used to give the input. This is the half wave rectifier first I am drawing. Here one PN junction diode is used. And here is the external load. So what used to happen? Okay. Input was given and you used to get an output here. So this half wave rectifier was able to rectify, was converting the AC through direct current, alternating current to direct current, but only half of the cycles, not the entire cycle. Input, output. Fine. Now, what used to happen in full wave rectifier? Let us see that. Here we use two PN junction diodes. Similar input we used to get here, but the output that we used to get rectified both the cycles. Okay. So that's why full cycle it used to rectify. So that's why it is referred to as full wave rectifier. Again discussed in class. You may refer the class lecture if you want to go in depth. Fine. Now that this is in forward biased first, then this becomes in at that time this is in reverse bias. Then in the next half cycle this is in the reverse biased, and this is in the forward bias. So current continuously flows through the load, right, and the direction didn't change. Fine. Alright, so this is a paragraph written on the photoelectric effect, right? Einstein explained photoelectric effect on a basis of Planck's quantum theory, where light travels in the form of small bundles of energy called photons. The energy of each photon is h into nu, where nu is the frequency, h into v of the incident light, h is the Planck's constant, the number of photon is in a beam of light determines the intensity of the incident radiation. Yes, correct. Okay. A photon incident on the metal surface transfers the total energy of free electron. A part of this energy is used to ejecting the electrons, work function, fine. The rest is used to give the kinetic energy, fine. Okay. Which of the following graphs are shown in the variation of the photoelectric current I with the intensity? Okay. So if I increase the intensity, what will happen to the photoelectric current? It is going to increase. Arey bhai. Suppose here is my surface. I had increased the intensity, that is more photons are falling, continuously increasing. More ejection will take place and hence more would be the photocurrent. Fine. Okay. This can't be the answer. The current is going to increase with the intensity. Current will increase with the intensity. Fine. Okay. Now let us move to the next question. When the frequency of the, now I've started feeling cold. Let me switch off the AC. When the frequency of the incident light is increased without changing the intensity, what will happen to the saturation current? Fine. So you hadn't changed the intensity, you had only changed the frequency, right? So this will remain same. Which of the following graphs can be used to obtain the value of the Planck's constant? Fine. So we know that EV naught is equal to h nu minus h nu naught. Okay. V naught is equal to h by E to f minus h by E into nu naught. Okay. So we need to find the value of the Planck's constant. So remember the concept of slope, y is equal to mx plus c. Y is equal to mx plus c or minus c. Huh? Y is equal to mx plus c or minus c. Okay. So this used to represent slope, but the graph should be between these two. So cutoff potential versus the frequency of the incident radiation. Red light, yellow light and blue light. So three lights are falling of the same intensity are incident on a represent the metal surface successively. Kr, Ky and Kb respectively are the maximum kinetic energy of the photo electrons. Okay, so we need to arrange the in order. So basically what is happening? Yellow light is incident, red light is incident and blue light is incident. Okay. Fine. We need to find what will, all of them are going to eject the electrons. Fine. They would be having some kinetic energy. So you need to arrange this only. That which of the three would be having the more kinetic energy. Fine. Okay, let us find it out. Kinetic energy max is equal to h into f minus h into f naught. Okay, chalo, let me tell you from here only. So if this factor is more, this will be more. Arey bhai, for example 7, this too is a constant na, depending upon metal. This is 10 minus 2. You get 8 here, you get 5 here. So if this factor is more, this will be more. Fine. Now, for this to be more, frequency must be more. Yes or no? For kinetic energy to be more, frequency must be more. And wavelength should be less. Because both are inversely proportional, right? Vibgyor. So you are only having blue, yellow and red into the picture. BYR. Wavelength of this is most, then followed by this and followed by this. Correct. So frequency of this will be more. Correct. frequency of red is more, kinetic energy, just a second. Oh, sorry, not red, this is blue. Okay, हाँ. So if frequency of blue is more, then the energy associated with blue will be most, followed by yellow and then red. Fine? Clear? Let us move to the next question. Which of the following, again it is an OR part, you may skip this. Which of the following metal exhibits photoelectric effect with the visible light? Cesium, having lesser work function. Alright, now this question is based on galvanometer. Okay. Let me just try if I can solve the entire questions without even taking the help of the paragraph. Let us see that. They have written the entire thing. The value of the current sensitivity. Okay. Now, what is current sensitivity? Deflection per unit current. Current sensitivity. NVAI into K phi. Even if you had forgot the formula, NVAI is equal to K phi. NVA by K is equal to phi by I. This is current sensitivity. NVA by K. Fine? Clear? Okay, so conversion of galvanometer into voltmeter or ammeter, like questions have appeared here. Let us discuss that. A galvanometer of resistance 6 ohm. So there is a galvanometer into the picture and resistance is 6 ohm. Shows full scale deflection of current at 0.2 ampere. So how much current can pass through this is 0.2 ampere only. Maximum current, not more than this should pass. The value of shunt to be used. Whenever I say shunt, so I am talking about a resistance in parallel. Okay, having resistances 6 ohm it is. How much current is passing? 0.2 ampere only, not more than that should pass. To be used to convert galvanometer into ammeter of this range. So how much current it must measure? It must measure 5 ampere maximum. This is the range of the entire ammeter. Now this entire is the ammeter. Fine. Which can measure 5 ampere. 0.2 ampere this has taken. So the rest 4.8 ampere must go through the shunt. Yes or no? So potential across the shunt must be equal to the potential across the galvanometer. Vs is equal to Vg. Vs is how much? Current through this into its resistance. V is I into R na. 4.8 into its resistance S. 0.2 into its resistance 6. Six, 7, 8. 1 by 4. 0.25. Fine. Clear, guys? Clear? Let us know a similar question we had discussed in the class as well. Let us know in the comment section what was the score you had got. The value of resistance of the ammeter in this case will be. Okay. So this entire is the ammeter. So they are asking you the resistance of this. Okay. So this is of 0.25 ohm, this is of 6 ohm, 0.25 ohm or 1 by 4 ohm. Okay. This has become a question of two resistances connected with each other in parallel. 1 by 4 ohm. This is 6 ohm. Equivalent resistance is how much? R1 into R2 on R1 plus R2. This is 10, 20, 25, 10, 20, 25. 6 by 25. Let me multiply this by 100 and divide by 100. This gets answer of 4, 24, 0.24. Equivalent resistance. A galvanometer is converted into how much time it is? 1 hour 21 minutes. Okay. A galvanometer is converted to voltmeter of this range by connecting it with a resistance R1. Okay, it is converted to a voltmeter. So this resistance must be connected in series. Okay. If R1 is replaced by R2, the range becomes this much of that voltmeter. Fine. The resistance of the galvanometer is. Okay. Galvanometer is converted to voltmeter of range. So here is the galvanometer having resistance G. You had connected it with a resistance R1. Okay. Now, here it can measure V volts. Here it can measure 2 volts. V volt and 2 volt. Achha, current I is passing. Current I only is passing. Current hasn't changed. Fine. Anything else? Okay. So can I write V is equal to current I into equivalent resistance? Yes, I can. G plus R1. Can I write potential is equal to current into equivalent resistance? Okay. This is first, this is second. You may divide the second by first. Okay. What they are asking you, the resistance of the galvanometer. G value is what they are asking you. Okay. 2V by V I gets cancelled out, send it that side. G plus R2. Send it here. G is equal to R2 minus twice of R1. R2 minus twice of R1. Option number 1. Clear? Okay. So if you would have practiced enough of the question that we had discussed during the class, right, and of course the homework questions, then these were very much solvable. You know. Again, it is an OR part. You may do it as homework. Torque is equal to NIAB. You can use. Okay. Again, a derivation based is there. Theoretical part. Okay, 5 marker it is, and more of the theory. And I think there is an OR part also. That is a question of self-inductance. Here it is mutual inductance. Again, a derivation based. I hope you guys can easily do this. Let me check some important question. Okay. Okay. Again, discussed in the class, draw array diagram of reflecting type telescope. Not refracting, reflecting type telescope. Cassegrain type, that too. Not the Newtonian one, Cassegrain type. Fine. and explain the formation of the image. State 2 important advantages of reflecting type telescope over refractive type 2 telescope. Again discussed in that class. The refractive type, it's costly, heavy and bulky, fragile it is, right, and chromatic and spherical aberration it is there, which are the disadvantages in the refracting type. Okay. So the reflecting type overcomes these. In the refractive telescope, focal length of objective is this much. Okay. Now they had come to refracting type. Okay. Find the final image formed at infinity. The length of the tube is 102 centimeter. Again, direct formula based it is. You can easily solve this. Okay. Now, if you observe, here they had asked about the telescope. Here they are asking about the microscope. Again, we had discussed this also in the class. Microscope they are asking. ना, ठीक है. So these diagrams वाले तो easily you guys can solve. ठीक है. Which microscope they had asked? Compound microscope. ठीक है. Fine. So these are theory ones, easily solvable. Okay. Now, again a few kids found difficulty in this question. 33rd. And I think this is having choice as well. Okay. This is having choice. Okay. But the choice is also difficult. Okay. Fine. 3 batteries E1, E2, E3 of EMF, internal resistance this much. Okay. I will be telling you the approach. Okay, let me write the values. 4 volt, 2 ohm. 4 volt is there, 2 ohm is there. Two ohm is there. Okay. 2 volt and 4 ohm. 6 volt and 2 ohm. Okay, very good. Now, are connected as shown in the figure. Find the values of the current passing through batteries E1, E2 and E3. Okay, fine. Current goes here. Let current I1. Let the current here be I1. Here let the current be I2. Enters here. So here current becomes I3, or you can write I1 plus I2. Then again I1 current flows back to this and I2 current flows back to this. Fine. Very simple. If you are done with this much, now it is very simple. You can apply the Kirchhoff's law to calculate the currents. That's it. Take any of the loops. I'm writing it as A, B, C, D, E. Take any of the loop. This first loop you can take and this is the second loop you can take. Only two values I1 and I2 are missing. Apply Kirchhoff's voltage law. Summation of voltages across a closed loop is 0, right? And you will get the values of I1 and I2. I hope this is solvable now. If you want, I can write the equation for you as well. Now, the ends of 6 wires, each of resistance R 10 ohm, are joined as shown in the figure. The point A and B of the arrangement are connected in a circuit. Find the value of the effective resistance offered by it to the circuit across A and B. So across these 2 points, you need to find the effective resistance. Now, those would have observed it carefully. 1, 2, 3, 4, 5. Let us know in the comment section what it is. Okay. Just forget this resistor for a while. Potential at A, potential at B. Between A and B, 5 resistors are connected. Between A and B, 5 resistors are connected. 3, 4, 5. This is A and this is B. Okay. Achha, each is of resistance R, that is 10 ohm. R, 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 R and R. And across this, another resistance R is connected. Okay. R into R, R into R, R square. That is, now this is in a balanced condition. You can remove this resistor. And done. These two are connected in series. Their equivalent will become how much? 2R. These two are connected in series. Their equivalent will become again 2R. This connected in parallel. Their equivalent will become R. Okay. Connected across A and B. Okay. Fine. 3 are connected in parallel with each other. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Solve this. 2R is the LCM. 1 plus 1 plus 2. R equivalent is R by 2. Simple. Achha, R is given to you as 10 ohm. 5 ohm. This becomes fine. Or part you may leave, okay, but anyways, they had given you, this one is also a direct type, hai na? They are asking you, length is given to you, cross sectional area it is given to you, hai na? Current is given to you, right? The density is given to you, right? Drift velocity they are asking. So you apply I is equal to A N E V D, where VD is the drift velocity. Fine. This one is slightly difficult, I would agree. So a lot of you may not be able to solve this if you didn't had a good command over the vectors concept. Fine. 2 point charges Q1 and Q2 are placed at points this and this. Okay. Okay. Let me just solve this with proper scale. One, 2, 3, 4, 3, 4, 5. Q1 is 16 microcoulomb placed at 3 I cap. 1, 2, 3. Q1 is 16 microcoulomb. Okay. Q2 is 3 I cap means 3 units along x axis. 4 J cap, 1 microcoulomb. 1, 2, 3, 4. 1 microcoulomb, 4 J cap. Okay. Find the net electric field E at this 3, 4. 1, 2, 3, 4. Electric field at this point P we need to find. Net electric field due to these two charges. Got it? Now, with the scale, it is very simple. Electric field we know due to a point charge, it is given by kq by r square. Electric field due to a point charge, it is given by kq by r square. Okay. Anyways, if you want, you can just use the concept of, with the help of graph only, you can say, you know, this much distance is 4 units, this much distance is 3 units. But if with the help of I cap and J cap you want to solve, you may solve this. Dekho bhai. At this point they are asking, this is 3 I cap, comma 4 J cap. 3 I cap, comma 4 J cap. Okay. So from the first chart, this is at a distance of 1, 2, 3, 4 meters. From the second chart, this is at a distance of 3 meters. Okay. Electric field due to this will be in this direction, E1. Due to this, it will be in this direction, E2. Both are at 90 degree. Net electric field will be under root E1 square plus E2 square. Fine. Okay. How much is E1? You can easily calculate KQ by R square. Q is how much? 16 microcoulomb, you may write. R square, 4 square. 4 square is 16, gets cancelled. 10 raised to minus 6 K. Achha, oh, I'm sorry, KQ by R square. E1 is this. Okay, ठीक है, चलो. E2 is how much? Due to this charge, K Q 1 into 10 raised to minus 6 by R square. This is 3 square is 9. K by 9 into 10 raised to the power minus 6. Fine. Now you need to find the net of these two. Substitute the values here. You will get the net electric field. Fine. Now, I hope you would have got the answers and solution of all your doubts. Okay. I realize that I must keep this session, right? Solutions wala session where you can get the authentic answers. Okay. I had seen many sources where answers were not correct, right? But yes, you can match your answers from here. Now, last advice for all of you, whether the exam went good or not, just focus on the upcoming exams, right? Whatever is done is done. Definitely you are going to trust me. The efforts you had put, you are going to get that much marks only. In general life also, you see that where you are standing right now is what you deserve, right? Not more than you get, not less than you get, right? So you have done your part. Now leave it. Focus on the upcoming exams, right? And thank you very much for choosing PW Gulf. Make sure you share this video with your friends who are looking for the solutions of this entire paper. Bye bye. See you in the next class. I do not know when it would be, but okay. Bye bye. Make sure you follow and subscribe the PW Gulf channel.